హాయ్ ఫ్రెండ్స్, నేను శ్రీనివాస్. మీరు చూస్తున్నారు కేబీ టెలివిజన్. వెల్కమ్ టు ఈ క్లాసెస్. ప్రపంచవ్యాప్తంగా నిత్యం చోటు చేసుకుంటున్న ఎన్నో ఆవిష్కరణలకు రసాయన శాస్త్రం మూలమవుతోంది. అందుకే ఈ సబ్జెక్టులో నిష్ణాతులయ్యేందుకు చాలామంది విద్యార్థులు ఉవ్విళ్ళూరుతున్నారు. సరిగ్గా వీరి కోసమే కేబీ టెలివిజన్ కెమిస్ట్రీ క్లాసులపై ప్రత్యేక శ్రద్ధ పెట్టింది. అనుభవజ్ఞులతో క్లాస్ నిర్వహిస్తోంది. మరి ఈనాటి కెమిస్ట్రీ క్లాసులోకి ఎంటర్ అయిపోదామా? నిన్నటి ఎపిసోడ్లో కెమిస్ట్రీ సబ్జెక్టుకు సంబంధించి కెమికల్ ఈక్వేషన్స్లోని కొన్ని అంశాలను నేర్చుకున్నాం కదా. మరి ఈరోజు ఎపిసోడ్లో ఇదే టాపిక్కు సంబంధించి మరికొన్ని అంశాలను తెలుసుకుందాం. మరి ఈ టాపిక్ను కెమిస్ట్రీ బోధనలో అత్యంత అనుభవం గల త్రివిక్రమ్ గారు వివరిస్తారు. మరి ఆ వివరాలేంటో తెలుసుకుందామా?
The whole equation to balance in 1, 2, 3 steps in a quick manner, oxidation number method should be developed. Suppose the same equation once again write MnO4 minus Fe2 plus the ionic form in acid medium giving Mn2 plus and Fe3 plus. This only we made into two parts separately, that balanced or this balanced, and finally we added in such a way that electrons get cancelled, which I did not show in the second method because already it was done in the same way in the first method. But all these are not necessary while balancing an equation when it is to be applied for any further higher concepts. If you recollect, while learning equivalent weights we use the term n factor. In redox reactions, the n factor we understood as what? Total number of electrons gained by the unit or lost by the unit, whatever the case may be. For example, permanganate ion here is meant for gaining electrons and this tends to lose electrons. This is going to get reduced, this is going to get oxidized, and that is the redox reaction. After noticing that it is a redox reaction, and in this way when represented called ionic form of the redox reaction, in balancing in oxidation number method we want to do it without making into number of steps. And students when aspiring higher examinations like IIT etc. should concentrate on this method more, because those regular simple methods we can easily learn in regular classes, and these big equations when to balance by that method we should concentrate on n factors deciding. For example, permanganate, here manganese is in plus 7 oxidation state. That's why I call it as oxidation number method, because we are relying on observation of changes in oxidation numbers. Plus 7 oxidation number here became plus 2 oxidation number. That means it gained 5 electrons, we understand automatically. Then what is n factor? We said in a redox reaction for the unit of this whatever the substance in a formula unit or however you represent, total number of electrons lost or gained by that whole unit. Here plus 2 is the final state and plus 7 is the initial state. Means from plus 7 state it became plus 2. It happens because 5 electrons are gained. 5 electrons are gained by this unit to become that. Here 5 electrons gained exactly by one manganese atom. Each manganese atom's oxidation state here plus 7 and that is plus 2, means for every manganese atom there is a gain of 5 electrons. Then how did you decide n factor? Depending on the number of such atoms also. No doubt here each manganese atom gaining 5 electrons. But in the whole unit, how many such manganese atoms are there? Only one. So you must say this is the n factor. So it is 5. N factor to decide equivalent weight etc. We study. The same thing here again we can apply. Like that iron, here plus 2 state became plus 3 state. So 1 electron, just it lost 1 electron. And that is by each iron ion, ferrous iron ion, and in the unit ferrous iron formula, there is only one iron atom. That means it is overall losing one electron. So 1 into 1, it is 1. You understand why I put here into 1 into 1? It is to tell that each manganese atom gaining 5, but in the overall, the whole formula, there is only one such manganese, so net gain is 5. Similarly, net gain here 1. In other formula, you may find 2, 3, and accordingly you must understand what is the net gain loss n factor. And from that we start. If you start like that, the balancing is very interesting. For example, here it is 5, it is 1. What does it mean? The whole unit gained 5 electrons, this whole unit lost only 1 electron. But finally, an equation is balanced only if this electrons gained by one, the lost by other one should be the same. So how is it possible? Only when you see one manganese, one permanganate ion, manganese in permanganate state is equivalent to 5 iron ions. There 90% balancing work is completed. Understand here? It is like interchanging the n factors. The n factor of permanganate in this way is 5 and n factor of that iron is 1. This 1 and this 5. If we just interchange that 5 here, that this 5 is there, that 1 here. Iron's n factor to manganese compound and manganese compound n factor to iron compound. That. So the equation is like this, in which permanganate and iron, ferrous iron, are interacting in 1:5 ratio. That fixation of the ratio based on observing the n factors is a big beginning, and with that balancing, interestingly, completed very easily, and definitely you can get advantage of this. Suppose in this way I understood that 1 permanganate is equivalent to 5 ferrous iron just by exchanging the n factors. Now Mn2 plus Fe3 plus are the products, and you see that the corresponding number of atoms adjusted. It is a simple completion. One manganese, but 5 irons. So 95% balancing work is completed. So main step is that observe the oxidation number changes, understand n factors, exchange n factors, you got the ratio. That ratio is key. When once that ratio is correct, at once you can finish it. When once that ratio is wrong, we can never do that balancing. So you must be very careful in deciding these n factors and fixing this ratio. And after that, it is the main step completed and simply to finish the next 2 steps. The next 2 steps based on the medium, because here still there is work. We need to adjust the charges, we need to adjust other atoms, etc. But main step is completed. For that second part, you can use this medium, acidic aqueous medium, as we did in half reaction, H plus and water. These are plenty available in the medium. Use them wherever you want, however you want, and see that balancing is completed. But for that also, this is the clue. In this method called oxidation number method, at this stage means nearly here at the end. Next step is delaying on the medium, depending on the medium, adjust the charge net. Total charges left side and right side carefully to be counted. 1 minus charge here, 5 into 2 plus 10 plus charges. So net of this is plus 9. Minus 1 plus 10. Net is plus 9. Look at the other side. 2 plus and 5 into 3, 15. 15 plus 2 plus 17. Plus 9 plus 17. A difference 8 units charge. Because it is 8 units charge, this is 8 units less by in plus charge, and that is